Last time, we had a summary introduction on factoring techniques that you will learn in ALEX for Module 2. Today, I'll do a summary of the uses of those on rational expressions, particularly on operation. A rational expression is just a fraction whose numerator and denominator are polynomials. In simplifying a rational expression, we follow the same model as simplifying fraction. In 21 over 24, we factor the numerator as 7 times 3 and the denominator as 8 times 3, and then cancel common factors. It works the same way with rational expression. For this rational expression, we also factor the numerator. Take out the GCF, 6, and you're left with b squared plus v minus 12, which you can factor by trial and error or by AC factoring into v plus 4, v minus 3. Denominator can also be factored, v plus 2, v minus 3. You can use either technique. For the moment, we won't show the details because the point of this is just to summarize that rational expressions work just like fractions, but we do a lot of factoring. We rewrite the numerator and the denominator just like what we did on fractions, and then cancel the common factor. In short, to simplify, you factor numerator. Factor the denominator. And cancel common factors. Multiplying rational expressions also works the same way as multiplying fractions. Multiply across numerator and across denominator, and then cancel common factors. So for this product of rational expressions, you multiply across numerator, across denominator, and then factor out what you can factor. This is factorable into x plus 1, x plus 2 by trial and error or by AC, and so is for x plus 4. That one. So we rewrite the numerator and the denominator and cancel common factors. We're left with this. So in multiplying, you multiply across numerator and across denominator. You factor what you can factor. And cancel common factors. Now, in division, it's similar to between fractions and rational expressions. First step is to flip the divisor. Second step is change it to multiplication. So for this one, it's 15 over 16 times 4 over 5. Write it nicely, and that's actually the same problem as the one we just did, so we know the answer is 3 over 4. So in rational expressions, you also flip and then change the division to multiplication. Now this is the same problem as the previous problem, so we know what the answer will be. So in dividing, you flip the divisor. And now addition. They're also similar. Remember that in fraction addition, you have to get the LCD. For this problem, it's 12, the LCD of 6 and 4. So the next step is to rewrite each fraction so that they have the same denominator, which is the LCD. So we need a 2 and a 2 to get a 12 at the bottom, and a 3 and a 3 to get the 12 for 7 over 4. And we add them up. It's similar with rational expressions. You get the LCD, first step. LCD of 6 and 4C, we've already seen that 6 and 4 have LCD 12, so this one will have a 12. There's a C here and a C there, so we must have that C also. The next step is to make the denominators of both rational expressions equal to 12C. For the first one, you need a 2 and a 2. That will give you the 12C. And then you just distribute 6C plus 10. For the second rational expression, you need a 3 above and a 3 below. That gives you the needed 12C. And then distribute the 3. So that's 9C minus 21. Now that they have the same denominator, add them. So combine the numerators, and if there's anything that will factor out, do so. Still cancel common factors, although in this example we don't need to do that. The key step here is to get the LCD. Rewrite. And after they have the same denominator, you can combine the numerators. And that's the summary for rational expressions.